So as we can see clearly here, plus and minus, right? We'll have what strong electric field. So that is the takeaway from this. Because they are closer in region, they'll have strong electric field. If it is of same charges, you can see here both are plus, right? If it is same charges, we'll have weak electric field. Weak electric field. And since we are dealing with the equipotential surface, there will be charges throughout. If it is plus or minus, we'll be having charges throughout. So there is no need for us to do any work to move a charge from one point to another. In equipotential surface, we don't require external work internet problem here. Yeah. So coming to this, what I was trying to tell is there is no need for any external work to be done to move a charge from one point to another. So normally we know if I want to push a chair from one point to another, what there is a work to be done. But in equipotential surface, there is nothing like that. So that is the main takeaway from this. Okay, and then there are some key points given below. No two equipotential surface intersect, work done is zero. So that's what I just told now. That is the most important thing. They are farther in the region of weak electric field. Plus and plus, weak electric field. Minus and minus, same charges in the weak electric field. Different in the sense, plus or minus, it is different. So it is strong electric field. So like that we can remember. Now coming to this particular thing, it is obtain the relationship between the electric field and the electric potential. Okay, so electric potential also, what is for example work, force into displacement is there, correct? W is equal to FD cos theta, correct? So same thing here also, instead of force we'll use what? Potential. Instead of force we'll use potential here to move a charge from one point to another. So we have to just only remember this, the last one. What is it? E is equal to minus dV by dx. V stands for potential, X stands for displacement. Okay, so this may be in the once the class is over, in the offline class I'll just explain you. Okay, so this is not that important for us, entrance nor for the board, but final thing it's important. E is equal to minus dV by dx. The most important thing is this particular thing. So I want everyone to pay the full attention only for this. After this we'll be doing one problem. Deduce an expression for electric potential energy system of 3-point charges in the absence of electric field. Correct. So what is the work done to move a point charge? So here it is 1/4 epsilon naught Q1 Q2 by R12. This is for what? Point from A to B. What is the work done to move a test charge from A to B? Correct. So we all know the basic formula is what? 1/4 epsilon naught Q by R. But here it is what two charges are there, Q1 and Q2. That's the reason I'm putting two charges by R12. Similarly, for AC and BC we will do, correct? And then we will add everything. So that is my final potential energy, or this is the work done, potential energy. Why potential energy? Potential energy in the sense, we know kinetic energy is moving, potential energy does not move. Equipotential, we don't need any external work, or it is not moving charges. Even if it is moving, the work done is zero. So that's the reason here we are making use of what? Potential energy here. So this is the important formula which we have to remember. 1/4 epsilon naught Q1 Q2 by R12 plus Q1 Q3 by R13 and Q2 Q3 by R23. So from this only I'm getting the diagram. Okay, so 1 by 4 pi epsilon naught q1 q2 by r12, q1 q3 by r13, q3 q4 q3 q2 by r23. Now with this we will do one problem. Let's see the problem now. I think everyone can see this thing, right? 3-point charges thing. Yeah. So what is the formula we have to use in this? So the same thing, if I want to write down here, I'll just write it down for you guys. A, B, and C, just like in the last. A, B, and C. Correct. So here it is what R13, here it is R12, and this is my R23. Correct. So this is A is what my Q1, this is my Q2, and this is my Q3. So they given the charges and everything. So what is the final answer for this? It is 1 by 4 pi epsilon naught Q1 Q2 by R12 plus Q2 Q3 by R23 plus Q1 Q3 by what? R13. So apply this formula and let me know the answer for this. What is the correct option? You should not take more than 1 minute. Nanocoulomb in the sense 3 into 10 power minus 9. Okay, meter. This is nano to meter, it is minus 9. 10 power minus 9 nanocoulomb. Clear? So I want you to try this thing and let me know the answer. This particular thing, 1 by 4 pi epsilon naught into Q1 Q2 by R12. This answer I need. And one more thing I forgot to tell you. Yeah, which should be there in the question, but entrance they may not give. 1 by 4 pi epsilon answer is what? 9 into 10 power 9. Okay, suppose if you're worrying about the final answer, it is not an epsilon naught. 1 by 4 pi epsilon naught value is 9 to 10 power 9. I want you to substitute everything and let me know the answer first. You can just message me in Zoom chat. This one. So this is from an actual paper, KCT 2015 physics. We can see all the questions are direct. We just know the formula. Q1, Q2. Q1 is 3 nanocoulomb. Q2, 9 nanocoulomb. 9 is in 10 power minus 10. If you want, you can take the 10 power minus 10 also outside. The answer can be done very quickly. Which is the option? Formula given, potential energy, that is U. Just now we discussed 1 by 4 pi epsilon naught. That value also I told you 9 and 10 power 9. Q1 Q2 by R12 plus Q2 Q3 by R23 plus Q1 Q3 by R13. We'll just add everything and we'll get the answer. That's all. Kindly do fast. Let's see who does it first. Answer is wrong also, I don't care, but kindly do fast. We'll just do a simple substitution here. Yes. What is the option, Srikanth? Then their answer is correct. Yes. Only one answer till now. So once you do all substitution, you get 8910 as the answer. I think option B should be the answer. See, epsilon naught value, nothing is there. 1 by 4 pi epsilon naught, that value is equal to what? 9 to 10 power 9. That's all. Everything is given in the question itself. Except 1 by 4 pi epsilon naught value, I already told you it is 9 to 10 power 9. That is 1 by 4 pi epsilon naught value. Okay, so that is nothing but 9 10 power 9 Newton meter square plus Coulomb square. That is all no need to write. Because entrance examination, we are not focused on the end unit. We just want the final answer. 1 by 4 pi epsilon naught value is 9 to 10 power 9. We'll just substitute the value and get the answer. That's all. So the option is B. Okay. So I think everyone can take a screenshot of the same. Because I only got one answer. So I'm going with that. Because even I don't have the answers for these kind of questions. Yeah, B. Okay, fine. So two answers I got. I am going with B as the correct thing. Yeah, perfect. Let me take the next one. Yeah. Now the most important thing is derive an expression for electric potential energy divided dipole placed in a uniform electric field. Okay. So here, as we have learned in the first itself, what we have learned first, electric potential thing, 1 by 4 pi epsilon naught Q by R. So basically from where we are moving the charge, from infinity to R, right? Correct. So similarly here also we have to move a charge from infinity to any point. Correct. So instead of a charge, we are moving what? Dipole here. Dipole. So for that purpose, we need something called torque. So basically, what is my torque? Torque is force into perpendicular distance. That is my basic torque formula. Force into perpendicular distance. But coming to this, the force is in terms of electric field. Correct. And this is been replaced by what? Dipole moment. Dipole moment, I told you what it is, P. So these are the important things to know before starting this problem. Okay, and torque is a vector quantity. So torque is equal to P cross E. Cross in the sense we'll get sine theta. Torque is a vector. Vector in the sense sine theta will come. Dot product. Dot product is what? Scalar. Cos theta will come. So coming to this, torque is equal to what? P sine theta. Now to move any dipole, correct? Yes, to move any dipole, we need what? Work to be done. So work done is equal to what? Force into displacement. Here force is what? Torque. Torque into displacement that given here as d theta. Because we are rotating, we are not moving it, we are just twisting the minus q to plus q. In the sense we are rotating the dipole, that's the thing. Okay, minus q, I'm just rotating and making plus q, and plus q, I'm making as minus q, just rotating the dipole. Correct? For that, we have to find the electric potential energy. So obviously, electric potential energy is what? Work done basically, dW. Okay, electric potential energy is basically dW. So here we have to move from what? Theta 1 to theta 2 because it is from the angle we are moving it. So dW is what? PE sine theta. And I told you integration we only do for the similar terms. So P and E are what? Constant. Constant will take it outside. And what is integration of sine theta? Just see this graph. Sine is in the top. Cos is in the bottom. Correct? Integration of sine is what? Cos. Integration of sine theta is equal to cos theta. But cos theta is what? It is in a negative y-axis. So I'm just putting in negative cos theta. That's all. So that is our formula for integration of sine theta. That is minus cos theta. Then you should put theta 2 minus theta 1 because upper limit minus lower limit. So we'll get what? PE into cos theta 1 minus cos theta 2 we will get. Cos theta 1 minus cos theta 2 will get. So that is my basic potential energy. So for the maximum and all, how do you get it here? For example, here if it is cos theta 1 theta 2, so what they're doing here is we need only one cos theta in this. Okay, for a simpler calculation. You got the point. So what I will do is I'll be making one of the thing as 0. How to make it 0? I will just make one of the theta 1 as 90 degree because torque again perpendicular distance. So I'll get cos 90. Cos 90 value is what? 0. So I'll get minus P cos theta. Now when this will be maximum? This will be maximum when theta is equal to what? 0. So I'll get cos 0 as equal to 1. So I'll get minus P. When this will be minimum means potential energy should be 0. The work done should be 0. So cos theta value should be 90. So I'll get cos 90 value is 0, then you will get U is equal to 0 for this. And coming back to the problem here, see this thing you have to do it and see, okay? Because even I don't have the options. So someone is telling A9910, 8910. Okay, once I come down, I'll check and let you know the correct answers.